Assalamualaikum warahmatullahi wabarakatuh. In this video, the students are required to conduct a research on future sustainable concrete or brick for potential application in civil engineering field based on study carried out by researchers around the world. So there are 4 members that will be presenting about the research of the assignment, which the first one will be about make concrete as a sustainable material for the environment by me, Za'imah, and second is review of the production of sustainable concrete with the use of alternative aggregate by Mohamad Syahmeer, and the third one, utilization of plastic waste in manufacturing of plastic sand bricks by Luqman Nurhakim, and last one is sustainable development of brick material using agro waste by Mohamad Naqib Afiq. In this, for my part, I will explain for the make concrete as a sustainable material for the environment. For introduction, sustainable material means having the least destructive impact on the environment and wasting of energy. In construction process, it is critical to consider sustainability requirements, particularly in new modern structures. Fly ash reduce the requirement for mine excavation and waste by acting as a cement replacement. So the objective is to increase the reliability of concrete. The aim of fly ash is to decrease carbon dioxide emission during cement production. And last one, unfavorable effect of concrete and trash are reduced in the environment. So for method 1, replace some cement with waste product, which is fly ash. So fly ash is the most significant component of coal combustion product, CCP, about 60%. So the advantage of fly ash concrete is that high quality fly ash can reduce the permeability of concrete at a low cost. In the addition of a specific amount of fly ash to blend cement is beneficial due to the synergistic impact of the clay and fly ash. Okay, synergistic impact means chemical substance or biological structure that interact, resulting in overall effect that is greater than individual substance. Fly ash give benefit to the environment and concrete. So for environment, it is to reduce the greenhouse gas footprint of concrete. Footprint means the impact on the environment of human activity in terms of pollution and the depletion of natural resources. So carbon dioxide emissions can be reached to 40 until 50% less than conventional cement. It reduces water consumption and increases the workability of concrete. So based on the table energy consumption between producing cement and fly ash is a byproduct from coal combustion and no process energy and non-energy emission are contribute. It is profitable to employ fly ash in the cement business in order to save energy and money. For concrete, it will give the benefit to the workability. Second, higher strength. Third, increase the durability. And last one, reduce shrinkage. From a project which was done by Professor S. Shanmugasundaram in India, the result for workability, fly ash type and conventional type has different slump, which is 60 and 40, but the workability is still same. And the compaction factor also same. Okay, next, result in strength test. So compressive strength of concrete with a certain amount of fly ash in the scale of 15 to 85 in different age is more than conventional concrete. Concrete manufacturer with an appropriate scale between cement and fly ash will be able to perform their preferred demand in project. So we can look at example for 28 days. There are 15 to 85 proportion for cement to fly ash. And the compressive strength is 23.71, which is higher than the other. For the second method is replace the inner aggregate with waste material by recycled aggregate. It is made by crushing concrete and sometimes asphalt to remedy the aggregate. Recycled aggregate are accessible for some type of concrete which include crushed stone, slag, brick and etc. So this is the result from a project which was done by Professor S. Shanmugasundaram in India for fine aggregate. Fly ash fine aggregate has low specific gravity than conventional fine aggregate, but for finer modulus, fly ash fine aggregate is higher than conventional fine aggregate. Okay, for coarse aggregate, fly ash coarse aggregate has spherical shape and the conventional coarse aggregate has angular shape, but the specific gravity for fly ash coarse aggregate also low than conventional coarse aggregate. For discussion part, concrete that produced by fly ash will be slightly lower in strength than cement concrete up to 28 days. Fly ash is not proper alternative for cement in concrete. Uh, it, it is not accepted in the construction industry because of the slow rate of strength at early stage, but it can conquer this problem concerning to low early strength by the gradual decline in water cementitious material ratio by employing a mixture of method. So therefore, fly ash concrete gains significantly higher ultimate strength than conventional concrete. So critiques on fly ash, we will critique on based on two, which is strength and toxicity. So for strength, some concrete manufacturers disagree with using fly ash instead of cement. This is because the slow rate of strength at early stage. And for toxicity, fly ash contain arsenic, beryllium, chromium, cobalt, vanadium, and etc. It may create human health and ecological concern. As example, fine crystalline silica in fly ash will be cause lung damage. So it is not good for our health. Based on Professor S. Shanmugasundaram, he says that specific conditions should be used with concrete. It is better that architecture avoid using it in design as concept as far as possible. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Sha'izan, and I will be presenting about the product of sustainable concrete with the use of alternative aggregates. As for the introduction, concrete still represents one of the most relevant and used material in the building industry, as it can be considered the second most consumed substance on earth. Aggregate plays a core role of a typical concrete mixture and are responsible for an unsustainable local natural resources consumption. The possible impact of alternative material depends on the construction industry size. The alternative material help both saving natural resources and reducing waste disposal by incorporating urban and industrial waste into concrete. The use of alternative material must consider the effect on both mechanical properties and durability, and specimen must comply technical requirements in the terms of resistance. What is the objective? The aim is to provide an extensive review of possible alternative aggregate and the effects of the substitution on the characteristic of the final concrete. What are the methods? Incorporation of more alternative and sustainable raw material will become future challenge of the concrete industry. Alternative material are a suitable answer to the rising cost of raw material and the consumption of natural resources. These are the three methods that can be implied. First is construction and demolition waste. Second, residue from waste management treatment. Third, other byproduct that does not fit in any previous sector. Look at the first method. As for the first method, firstly we look at the ceramic. The consequence of using alternative cost aggregate is the reduction in density caused by the lower bulk density of reduce if compared to natural aggregates, as it affects the workability too. Results have shown that concrete produce up to 30% of fine ceramic aggregates reach similar or improved mechanical properties than conventional concrete. The problem came when the selective process on producing a high quality with more stable aggregate, or it turns the result of a specific kind of waste in the demolition phase. Now we look at the recyclable aggregate. Recycled cost aggregate shows a wide range of variation of slump depending on replacing level, water absorption rate, and sensitivity to corrosion represent two additional dangerous side effects to the aggregate. Recyclable aggregate as other alternative material represent an environmentally friendly solution to prevent the amount of waste disposed in landfills. This is the second method, reduce from waste treatment. First, we look at the ISSA, incinerator sewage sludge ash. It reduced from waste treatment led to a reduction in workability due to the hygroscopic behavior of ISSA particle and their increase in porosity. The use of ISSA fine aggregate in concrete brought an enhanced cohesion in the matrix structure. As a result, an increased strength has been detected. MSWI is Municipal Solid Waste Incineration. Municipal solid waste incineration fined as fine aggregate influence physical properties of concrete which decrease the workability gradually. Municipal solid waste incineration ash-based concrete clearly showed the influence of recycled fine aggregate on compressive and structural strength at lost. Leaching of plumber and zinc increased in municipal solid waste incineration ash concrete in the long term, which produced high concentration of pH to the environment. Lastly is the third method, other byproduct that does not fit in the previous sector. The paste workability increased together with the share of glass powder added, but it decreased in the curing days. The effect is due to the alkali-silica reaction. Glass powder registered a loss of both compressive and flexural resistance due to the particle size that can cause the cracking of the aggregate due to the smooth surface texture. Low porosity of specimen shows a positive effect, increasing the resistance to chloride ion penetration. The low porosity and the finer size of glass particles integrated in concrete have positively affected the resistance to chloride ion penetration. As a discussion, the increased urbanization is leading to a massive production of concrete due to the increased requests which use aggregate that give an effect on the non-renewable resources. The table in the findings summarize the result of the main alternative aggregate among those investigated, resuming some of the most relevant properties from each element analyzed. Incorporation of waste and discard led to decrease in workability and density and pozzolanic activity than natural aggregate used. Ceramic shows the better overall performance mechanically, increasing the compressive, flexural and tensile strength compared to the target of the reference concrete. Other alternative reduces the mechanical performance and glass recording the worst behavior out of it. As data collected state, the substitution rates are lower for fine aggregate if compared to coarse ones. This underlines the higher impact that fine aggregates substitution has on final product compared to coarse ones, as they influence cohesion and resistance of the mixture. As for critics, the objective of this research is about possible alternative aggregate and the effects of the substitution on the characteristic of the final concrete. As for my opinion, the research that is being done is basically from many references that being done by many researchers in every regions in the world, and the author of the journal has narrowed the content to the very detail of each comparison of possible replacement of aggregate. The results obtained was convincing enough, as the data is not only from the author itself but by many other researchers have done the same study about producing an alternative aggregate in getting the same result as the normal concrete mix. There are some of parts where it is unclear on some of the aspects such as environmental, such as mechanical properties for recyclable aggregate is not stated clearly in the journal, but most of the research shown were at the top. The research will contribute well to the future product on replacing the substitution material, but the main point in implementing it is based on the exposure of the material to the public, which plays an important role too. That is all for me. Thank you.
Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Nurhakim bin Norhan, and today I'm going to explain about utilization of plastic waste in manufacturing of plastic sand bricks. Alright, for the introduction, as we all know that plastic waste is one of the material that is hard for us to dispose because it's a non-biodegradable substance. Alright, and the number of plastic waste is increasing day by day. So, the objective of the test in this article is to develop an efficient way to utilize the plastic waste by producing a brick, and from that test, they can lower the consumption of natural resource and reduce the plastic pollution by reuse the plastic waste. Alright, the methods of the test that have been done by the author of this article, they have gathered the plastic waste and different it from the other waste. And then after that, they dry the plastic waste to remove any content of moisture. And then crush the plastic waste in small pieces with crushing machine. After that, they crush the small particle again into a fine size pieces. And then they use a ratio 3 to 7 of plastics and stone dust. After that, the stone dust that will be used need to be sieved for a smaller size than 4.75 millimeter using the sieve analysis. Alright, and then they heat the stone dust on a furnace, heat the fine pieces plastic waste on the furnace too until it melt and turn into a liquid. Alright, and then they insert the stone dust into the melted plastic and make it a mixture. And then they pour the mixture into the mold and let it dry in the mold and remove it from the mold on the next day. So they let it dry for about a day and then they wet the brick. Alright, as you can see from the result, the brick doesn't absorb any water because the water absorption percentage is 0%. And then the color test, the author state that the color is mud color. And then the brick also perform well in the compressive strength test, which is a little bit better than fly ash bricks and third class clay bricks. Alright, for the discussion, we can see that clearly the plastics and sand brick can perform well in the compressive strength test, and it can perform better than fly ash brick and the third class clay bricks. Alright, the physical properties like the color of the brick is also familiar with the concrete color, which is a mud color. And then this production of bricks can help improve the way of handling massive plastic waste pollution, which we all know the number of plastic pollution in the world is increasing day by day. And then it's also can reduce the use of natural resource like clay. They also have, the number have been decreased day by day. Alright, and for the critique, I found that the compressive strength of the brick that have been produced is a little bit low, and maybe it is suitable for us to use to build like a small house or a small construction. But for a bigger project like building a high-rise building, it is not suitable. Maybe they can increase the compressive strength because we need a maximum strength to build a high-rise building to ensure its safety. For the hardness test, maybe they can make it more detailed on how they have done the hardness test and write a more detailed result on it, so we can be more confident with the result they have come out. And the clay bricks that used in the comprehensive test have no explanation to detail about it and convince the reader. And then the studies is helpful to develop new alternative and producing bricks, but more detailed research need to be done before we can use the method for producing these bricks. Alright, for the conclusion of the sustainable bricks, we need to be creative with things around us and always find a way to reuse it. Maybe like the plastic waste can be used to produce a bricks, and then the method that have been done can help us reduce the plastic pollution that slowly destroy our world. And then the plastic and sand bricks bring us alternative to people with a better price. Alright, maybe they can make the price of the bricks more cheaper than a typical bricks. Other than that, it showed that many research done to design the green bricks material have been reviewed. By this method, we can conclude that it is an environment friendly because no pollution happen to make the bricks, and even it's suitable for small construction, but it's helped us to know about it. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Afiq bin Hanuar, and as my part, I will tell about the sustainable development using brick material using agro waste. Okay, so for the introduction, nowadays on a daily basis, brick is considered one of the most suitable building materials in the construction of structure. Commonly, it used brick by prepare using clay or cement concrete. This is a lack of environment such as carbon footprint because it is environment unfriendly. So the reuse of this waste as a sustainable building material seems to be a good way out, not only for the pollution problem but also for the landfill problem and the high cost of building materials. So now we move to the methodology, findings and discussion of study on agro waste brick. So first, from Che Ming Chen, 2011, the methodology properties of clay bricks by editing two natural fibers. It can be studied that although clay bricks are well known in the construction industry for their flexibility and low cost, they greatly affect the environment and sustainable value. He also studied the recycling of agriculture waste by taking the fiber of pineapple leaf and branches of oil palm fruit and then editing brick making. In this way, green brick materials are developed, which leads to the reuse of natural waste, avoiding hazardous waste dump and open burning. Cement also added as a brick binder, and both unburnt and fire brick are prepared. Cement was found to dominate the compressive strength of brick. Unburnt brick crumble when immersed in water, while baked brick show cement depend properties in the water absorption and density change. Next one is Illich Quesada et al. 2011. The methodology studies on clay bricks with various parts of waste materials such as urban sewage sludge, baggage and sludge from the beverage industry, olive factory wastewater and coffee waste. Bricks are produced with an optimal amount of waste. All the waste studied can be used effectively for poor formation. The incorporation of urban sewage sludge, weaving industry sludge and baggage in the clay bricks increase the number of open pores and slightly improve the terminal insulating properties of the bricks. And the incorporation of coffee wastewater and olive meal in clay bricks slightly increase the open porously and the closed property part, thus maintaining the compressive strength and improving the terminal insulating properties of the brick. This can be proved by the data. We can see the water absorption which is increased to 35% and compressive strength is decreased to 90%, terminal insulation increased to 8%, and terminal conductivity increased 90%. The next is Adazabra 2017, the methodology in incorporation of spent sea waste into clay materials as a sustainable material. The need of effectively spent sea waste disposal has led to its addition in brick compositions. The chemical components, mineralogy, composition, and the terminal behavior of both the clay materials and the depleted series residue were internally tested. The analysis that improvement the incorporation of spent sea reduced result is an increase in water absorption but a decrease in compressive strength. Therefore, stack brick are considered suitable for the construction of load-bearing structure. The researchers conclude that the potential benefit of growing bricks from clay that include spent sea waste include better drainage agents, economic compaction, and sustainable brick making. So the next one is Ornam 2016. It studied the influence of sago husk as a filler on fly arch bridge as a non-structural element of buildings. Specimens were formed and then stored in the sun to dry and then baked at 550 degrees Celsius in a furnace zinc plate and aluminium foil for 2 hours. Various tests were performed on the brick and the gradual decrease in compressive strength was observed with an increase in the content of sago husk. It was also analyzed that the high content of sago husk result in a low specimen density. So the last one is from Mohamad Sahid Arshad and Dr. P.Y. Perwait 2014. The method studied to reduce the quantity of clay in brick composition using natural waste materials. Bricks are prepared by inserting orange peel and coconut waste along with clay and paper mill waste as binders. The use of the natural waste serves for the purpose of solid waste management. The addition of rubbish is done to reduce the shortage of clay material in many parts of the world. The waste material was found to be porous and fibrous structure by monograph analysis. It has been seen that when the clay content reduces, the brick become lighter, but a composition where the soil content is 30% and rest consists of the paper mill waste and orange peel. It does not produce a good bond with each other and crumbles when completely dry. From the experimental study, it can be concluded that the finished brick is lightweight, observe shocks and meet the requirements of compressive strength. It also confirmed that the brick making process is so simple that it can provide opportunities to rural entrepreneurs with unskilled labor in development countries. So from that, what I can critique is from all the studies, the result mostly show that the compressive strength is low. It may be suitable for small construction, but by that it also have that no wastage of agro waste. Next, the data should be more specific, such as tell what happened if still used this way in a mega project, and I think it's not suitable for it because it's easy to collapse. Next, there is some part not too clear, like how many percentage that we need to use to mix to make a brick. But overall, we can see that by using the agro waste, it is eco-friendly because no pollution happen. This study can tell people that there is other thing can be replaced to make a brick and help us to find the other efficient way, but we need to explore more about it, like the method that we want to use. So this is our reference that we have been done. It's from the production of sustainable concrete with the use of alternative aggregate. The next one from make concrete as a sustainable material for the environment. And the next one from utilization of plastic waste in manufacturing of plastic sand bricks. And the last one sustainable brick materials incorporating agro waste. So that's all from me. Thank you.